Atop the Colorado Plateau in southeastern Utah is one of the world's most breathtaking places, Canyonlands National Park.
I think the main reason that people come to Canyonlands is they want to see this landscape that's completely unique. Carved sandstone landforms, giant cliffs, deep sinuous canyons, and all of that is defined by geology.
Canyonlands is one of the great geology parks. People often wonder, how did this place form? And there are several ingredients that have combined to make Canyonlands.
The story begins millions of years ago, when North America looked very different than it does today.
Rocks in Canyonlands were deposited before the age of the dinosaurs.
The oldest rocks in Canyonlands are approximately 300 million years old. It started with deposition in a shallow sea that eventually dried out. As time went on, sand filled the basin, and there were sand dune deserts here. Eventually, climate shifted and became wetter, and rivers started to move into the area, depositing red silts and muds.
Deposition continued over the next 200 million years, while the area remained near sea level. Wind-deposited sand dunes alternated with river-borne sediments, creating layers thousands of feet thick.
After being deeply buried in the passage of geologic time, the sediments were compressed and cemented into rock. It's that rock that forms the landscape that we see today. Tectonic forces, starting about 60 million years ago, began lifting those sediments, lifting that landform into a high plateau. That was the formation of the Colorado Plateau.
As the land rose over millions of years, thousands of feet of sedimentary rock eroded away, carried off by water.
The shift from uplift to erosion in Canyonlands began probably sometime as early as 20 million years ago. The real canyon cutting didn't begin until about the last 4 to 6 million years. All of the canyon forming that we see today happened from that time frame till now. Canyonlands is carved by water, both liquid and frozen. When it rains, the canyons flood. This creates a slurry of water and sand, and that scours the canyon walls and carves into the canyon bottoms. A more subtle erosional force called ice wedging occurs also, and this is when snow melt seeps into cracks and fissures. That water refreezes and expands at night and causes those cracks to widen and the rock around them to crumble and collapse.
While erosion is the primary sculptor of Canyonlands, it's had a surprising helper. The deeply buried salt left behind from the ancient seas has influenced much of this landscape. These salt tectonics are especially visible in the Needles district, where they have created grabens or collapsed valleys.
Salt as a rock has several important characteristics. One of them is the fact that it can flow plastically, like silly putty.
So as that salt flows, the brittle sandstone above it fractures, sometimes creating valleys where the sandstone is literally collapsing into the salt beneath it.
The grabens is a great place to study the processes that are still shaping the Earth. Because the salt tectonic features are so well exposed and so well understood, geologists from all around the world come to Canyonlands to study them. Canyonlands is continuing to be carved today and tomorrow and well into the future. The processes are going to happen sporadically, the heavy thunderstorms, the big rock falls. But adding it across time, Canyonlands is going to continue to erode and to change.
Canyonlands National Park, from its towering spires to its winding canyons, is an ever-changing geologic story millions of years old and still being written today.